So good Thursday afternoon, everyone. Welcome to lecture 3 in mathematics for construction. So from this week, all classes will be on a Thursday, right? The first two classes were on Wednesdays. What last thing we did, we talk about, these are some primary school concepts here, just to review for everybody. Factors and multiples. Was a multiple, was a factor, was HCF, was LCM, right? A quick review. This is one technique of finding HCF and LCM for fairly small numbers, right? If I give you a 2 7-digit number, I do expect you to use this method. I have more sophisticated methods that you could use, but we don't need that kind of ammunition for this course, right? And we started some basic algebra, right? We started with numbers. We talk about indices, and I kind of show you the magical formulas for letters that come from numbers, right? We concluded with these formulas down here. These are the laws of indices, and we try to convince ourselves that these things are correct based on numbers, as we saw up here, right? What do these numbers mean? Okay, so just to reassure you that these things are not magic. They came from somewhere, and you need to understand why rather than memorizing. Mathematics is not about memorizing. Mathematics is a way of thinking about the world. You have to train your mind for several years to think about the world in a computational, logical way. The more you memorize, the less good you will get at math. You'll struggle your whole life with math if you try to memorize things. Okay. We had some homokerat indices, right? So what I want to do, I want to kind of jump away from that a little bit and use the idea of HCF, okay? HCF, not so much LCM, but the idea of HCF, but this time, for a set of terms, right? HCF of a set of algebraic terms, okay? So we have here HCF of algebraic terms. So we know how to find HCF of 2 or more numbers, okay? This is something we did last week. What happens when we have letters and terms and expressions, right? So you could find the HCF for 2 or more algebraic terms by following some simple steps. Okay. Do you all know what a term is? What is a term? What is a expression? What are these things? Anybody knows what those things are? We need to go over that. Anybody?
So I think we might have to go over that.
Yeah, all right, cool. So let me undo this.
Just a refresh. Yeah.
Before I do this, right? We'll start basic algebra, right? Hold on, I'm trying to find. So I have lots of notes to get today, right? Basic algebra, okay? So this is a review of everything kind of quickly, right? You have the notes, so you'll always be able to go through it. We want to switch focus from dealing with numbers, because we were dealing with numbers in lecture 2. When we started talking about powers of numbers and we introduced the laws of indices. So this is kind of us starting with algebra, okay? So basic algebra, right? We need to start working with letters that represent unknown quantities. The arithmetic of letters is the same for numbers, but it takes some getting used to, as it's not always easy to combine letters the way we can with numbers. Like 5 by x is 5x. You can't combine it, but 5 by 2 is 10. You follow? So if Alice has X dollars and Bumho Y dollars, when you add up the money, you don't know what the thing that thing is. So it's X plus Y. You can't do anything with that other than say X plus Y. you don't know value of x of y, so we can't give the final answer, but that is the answer. X plus y is the sum of two unknown quantities, but you can write an expression for the total sum of money. That's the idea behind algebra, representing unknown quantities with letters. Okay, what's a term? So a term is composed of arithmetic sign, like plus or minus, a number, and 0 or more letters raised to different powers. You may not have a number, right? I could say an optional number, and 0 or more letters raised to different powers. For example, -4 is a term, is a number, but it's still a term. 0 is a term. 5/2 is an improper fraction, but it's still a term. This is what it could have a sign, it could not have a sign. It could have a number, it could not have a number. It could have a letter, like these three here don't have letters on them. X don't have a sign, the positive sign is understood there, and it don't have a number, 1 is understood, right? We'll talk about more that in a while. You can have all, like you could have a sign, a number, and letters raised to different powers, right? So all these things here are terms. When the sign is not present, plus is understood. When a number is not present, we assume 1 is there. Ordinary numbers and fractions are terms. Okay. Now hidden items. Okay. This is something you should have learned in primary school. Right? It's very, very important. The integer 7 by itself has a few hidden items around it. Hidden items come into life. They appear when 7 participates in different kinds of interactions. Okay. So if you have 7 and you add to 3/5, okay, suddenly 7 is 7/1. There's an invisible 1 underneath 7. The whole number 7 is really a fraction, 7/1. Okay, the 1 is hidden, right? If we try to subtract 12 from 7, suddenly 7 has positive sign in front of it, and we say plus 7 minus 12. We start at 7 in the number line and we go 12 places to the left, and we end up at -5. So that plus sign is hidden, is invisible. It pops up when 7 decides to behave a certain way. Okay, when we try to divide 7 by 7 to the power 5, suddenly 7 is 7 to the power 1. Okay, and then we use the laws of indices here. When you divide on the same base, you subtract the powers. So that's what we did here. And then we end up with 7 to the power -4, which we convince ourselves is 1/7 to the 4. This is third rule here. Right? So 7 is actually represented like this, plus 7 to the power 1 all over 1. So we could generalize x is the same thing. X by itself is not really x. There's an invisible power 1, there's a positive 1 in front of it, and there's a denominator of 1. Okay. So after talking about, what a term is, sorry, an optional. What are like terms then? So like terms essentially have the same letters, and each letter in each term is raised to the same power. So the coefficient of a term is the non-letter part, right? The number in front of the term, that's called the coefficient, right? So number and sign in front of the term. So all these here are like terms, but x doesn't have a number in front of it. Actually it does, but we didn't write it. The positive 1 is understood. Similarly, this one, positive 2 is understood, right? And we could have negative numbers and so on. Each of the above terms are like terms, they just have different coefficients. The coefficient of this last term here is -9/8. Like terms can be added and subtracted like ordinary numbers, right? Once they're like terms, we can combine them. So we have some rules there. When these signs are the same in front of them, we add them and keep the sign. We add the coefficients. So for example, 12x² plus 5x² is like 12 apples plus 5 apples. You're gonna get 17 of the same thing, right? Here we have two numbers being added, right? Even though you see the minus sign, it's actually being added, okay? what we do, the numbers are different, but the signs are the same. So we add the numbers and we keep the sign. When we add the numbers and the signs are different, we subtract the numbers and we keep the sign of the bigger number. So if I have negative 15 plus 19, you just subtract the numbers, you'll get 4, and you keep the sign of the bigger number, which is positive. 19 is the bigger number. So positive is the answer and the sign of the answer. And then we can leave out positive. You don't need to write positive p squared q. You could just say 4p squared q. Okay. So you kind of had to start imagining things a little bit differently. There is no operation called subtraction when you think about it. Yeah. That is a lie they tell you in primary school because your mind couldn't deal with it at the age of 6 and 7. Everything is really addition. Okay. What we do in here, this example here that I highlighted, you add in negative numbers. You could actually say a plus sign in front of it and just put brackets. Okay. This is really what is happening. There is no operation called subtraction really. It's really addition. We add in negative numbers here. That's why I don't tell you all in secondary school a plus by a minus is a minus. They give you another trick to help you deal with the inconsistency, right? But it's really addition. You're just adding things. Here you add in this example here, you have negative 15 and you add in 19. Or you could think about it another way. You have 19, but you add in negative 15. Okay, if you have $10, you could add negative $5 and you will get $5. It's really addition all the time. Multiplication is addition too. What do you think 3 by 2 is? Is 3 added to itself 2 times or 2 added to itself 3 times. Multiplication really is addition, just repeated addition, right? If you approach everything with just one operation, addition, you have less rules to remember, you know? The less rules to remember is the more obvious mathematics is and the easier it is to get on with what it is you're trying to do. So subtraction is basically adding a negative number. When we say something like 5 take away 3, that's how people in primary school talk, 5 take away 3, right? When we growing up now, we do more complicated math. 5 minus 3, that's really plus 5 being added to negative 3. Okay, you view it on the number line in directed numbers. You start at plus 5. If you're adding a negative number, you go left on the number line. So we'll jump 3 places and end up with plus 2. Okay, so this first question here. What is this? What is this? What would this be equal to? 2xy plus 5xy minus 12xy. How you would do this? Okay. First of all, you can't combine them unless they're like terms. So you have to ask yourself, are they like terms? So all the terms have x raised to the power 1. All the terms have y raised to the power 1 and no other letters. So they are all like terms. So it's essentially you're dealing with the coefficients alone. So that is 2 things plus 5 things. So I get 7. And then out of those 7 things, I'm adding negative 12. Okay, so I'm gonna end up here with negative 5xy. Okay, just dealing with the coefficients. If you have 2 apples and you add 5 apples, you're gonna get 7. If you add negative 12 apples, then you're in debt. You owe somebody 5 apples. That's really what negative is. You owe somebody, you have a deficit. Okay. So we could say, well, okay, this is really 7 minus 12, or 7 and negative 12, which is negative 5. Okay. If you want to see it done with just numbers, you would just do this here. Okay. Pretend you don't see the letters, then technically this is where you have 2 plus 5 net minus 12. You add the 2 and 5, you get 7, then you take away 12. That is really plus 7 plus minus 12. You're really adding a negative number to a positive number. And we know a plus by a minus and a minus. So when we combine these 2 signs here, we get negative 12. and the plus sign is understood. So however you want to do it, this is pretty much it, okay? How you would do this one? What is this? What will be the answer for this here? If I write a question without letters, if I have 13, take away 23 plus 7. If I had to do this question here, I could combine the first two numbers, right? 13 take away 23. 23 is bigger. You're taking away more than what you have, so you'll end up with a deficit of 10, right? And you have a deficit of 10 and somebody give you $7. So think of deficit as owing money. I owe somebody $10 and I get $7. I still owe them. If I pay them 7 out of the 10 I owe them, I still owe them money. Okay. So you're really adding the coefficients. So this answer is -3. And then the x squared y just comes along for the ride. Right? It's like formality. Okay. So yeah, you had to understand how to add numbers before you could start doing algebra, because it's an extension of that. Lots of people get confused when they see minus signs and they trip up and they make errors, but that's not something inherent to algebra or letters. That's something with numbers, as this last example here shows. If you can't do this example here, you're gonna struggle with letters, okay? Letters builds on numbers. The laws of algebra is the same for numbers, right? So try these two questions here. What you think the answer would be? So this example here, 3xy plus 7x squared y. You can't really combine these. You just have to leave it like that. You can't combine them into one term because they are not like terms. I have xy here, I have x squared y here. They are unlike terms. You can't combine them. Basically, you just have to leave it. Okay. You can factorize it if you want, which we'll get to, right? But it's still not one term, right? Similarly here, this is a x squared y term, and this is a xy squared term. You can't really combine this. It's, if you have 5 mangoes and 3 apples, you don't get 8 of the same thing. You know what I mean? You don't get 8 of one fruit when you add 5 apples and 3 mangoes. It's two different things. It's not unlike terms. You can't add them to get a single thing that is the same 8 times. I hope you all understand what I'm saying. So this was a trick question. You cannot combine these into one term. I'll leave it just so, or you can factorize it. Okay. So we found out what terms are. We found out what like terms are. What are expressions? So expression, as you see here, is one or more terms being added or subtracted, right? So one term is an expression, like 12. 12 is an expression. It's just a very simple expression. It's an expression consisting of one term. Similarly, -5 or 0, those are expressions because they're also terms. So all terms are expressions. Okay, but not no expression. You can't say all expressions are terms. Right? So this 4p, this is also a term and is also an expression. But 3x plus 2y you have more than one term there being combined with a plus or minus signs, being added or subtracted. So that is actually an expression. Okay. And you could have 3 or 4 as the case may be. Sometimes you write brackets around it. This is one expression here, 3x plus 2y. This is another expression here, 2m plus 3n minus 4p. If you have to combine separate like terms, you should always group terms together before adding them, right? So look at this example here. I have 13m plus 2xy minus 7m minus 5xy. The best thing to do is to group the m terms together and group the xy terms together. So all the m's are on the left and all the xy's on the right. You put brackets around them to kind of simplify your work. Notice you can't always do brackets like this if you have a minus sign here. You gotta be very careful when you're inserting brackets into a question. It's harmless here, but it could not be harmless with other questions. So 13 take away 7 is 6. And what we add in? We add in 2 minus 5, which is minus 3. So I have 6 or something and I'm taking away 3 from it, right? But is unlike terms. So plus by minus is a minus. We have 6m minus 3xy. You could factorize this answer later on and show you how to do that. But this is essentially how you would combine several terms together, right? Try this question here. What will be the final answer for this question after you combine the terms? Okay, try this. So first you group the terms together. Okay, so I have the x squared grouped together. 27x squared negative 8x squared, and then the 12 minus 15. So after you group them together, you will get this final answer. You can't really simplify this any further into one term. You could factorize, but we'll leave the answer so for now. Try this question here. First step that you should do is organize the terms in a certain order, right? So we want to group all the p squared q terms to the left and all the pq terms to the right. And then we simply add the coefficients for each group of terms, right? So this first group here, 13 plus 14 plus 8. That's a kind of biggish number, right? 13 plus 14 is 27, and 27 and 8 is 35. So this would be 35p squared cubed, right? And then what's the next thing that comes after that? This is the PQ terms, right? Now all of them are negative. All 3 terms are negative. So when you add them up, you will just get a bigger negative number. So we could keep the sign. We could say minus and then figure out what these numbers are. Okay, so 7 and 5 is 12. 12 and 9, you're adding 9 to 12. That would be 21. And then you just put the term letters itself, right? That's the final answer. I could factorize this, but for now, that's good enough. This shows that you know how to combine it. Now, sometimes you have to expand brackets, okay, to figure out what the term is. So, you know, you could have something like this here, where you have to do a little bit of work first, right, before you figure out what the final answer is. Okay, so try this one, try expanding. Yeah, what we're really using is something called the distributive law. So what that means is you multiply everything inside the brackets by everything outside the brackets, okay? So this first bracket, 3x plus 2y, we multiply the 3x by 2 and we multiply the 4y by 2. And we do the same thing for this bracket here. Multiply the 3y by -3, multiply the minus 4x by -3, and you'll get 4 terms, and then you group them and combine them. So try this one and see if you remember how to do this. Okay. You have to be careful when you removing brackets. Okay. What I suggest you do is multiply signs first, then numbers, then letters. Okay. So for instance, this is +2 by +3. So you know you're gonna get a positive number down here. So I don't put a minus sign. Then I say 2 by 3, which is 6. And you know, 1 by x is x, so that's 6x. Then the 2 by 4, that's +8y. Okay. -3 by +3, it'll be -9y. And then I have minus by a minus, which is a plus. So I'll get plus 3 4s are 12x. Right. So I deliberately put that minus sign there to mess people up. Okay. You rewrite the question, and you could take the 12x and put it next to the 6x. And the 8y and 9y are next to each other like this, right? And then you just deal with the coefficients. 6 and 12 both are positive. Okay. I'll get 18x. And if I have $8 and somebody take away $9, then I owe them money. So the answer is -y for that part there. Right. So this is how I would work that out. Don't try and do it in 2 lines, right? Take your time and do it in the 4 lines so that you could see you're working. You're surely working in this course, right? So this is a chance to redeem yourself for those people who didn't really get this one out, but don't be fooled, this one even harder, right? So take your time and try it. We have to multiply signs first, then numbers, then letters. So negative by positive is negative, 3 5s are 15, and then we have a p. Negative by negative is positive, 3 by 7, 21, and then we have a m. Negative by positive is negative, 4 2s are 8, and we have a m. Negative by negative is positive, 4 8s, 2 p. We just group like terms together, right? So -15 plus 32, that is 17, positive 17, right? And 21 take away 8, that's also a positive number. That should be 13, right? Because 7 and 13 and 7 is 20 and 1 is 21. So this should be the answer there for that. So, you know, these things, you just have to be careful with the signs, right? And we could get more difficult, more challenging, right? So I'm gonna give you some questions to practice for the while to get, because some people need a little Some people need a little bit of practice with this. Okay. So these are 3 questions here for you to try to get some more practice doing this, right? Okay, let's do this one here. This is 28p minus 12m minus 10m plus 30p. Again, you just multiply whatever outside by whatever inside, right? Then we could combine like terms together in the next line. Remember, I'll show all your work, you know? So the 30p, I could just grab it and stick it here. So 28 and 30 and 12 and 10, right? The 28 and 30, that's 58. Minus 12 minus 10, you're getting more and more negative. Minus 12 means you owe somebody $12. And then you add a negative 10, it means you owe them an next $10. And you're going to owe them more. Right? So this is the answer for this one. And this one, this is interesting. Negative by positive, negative 14y plus 2 5s are 10x minus 18x plus 3y. How I get out plus 3y? Negative 3 by negative y is plus 3, right? Let me just rearrange these guys here. Take this y, stick it here. So minus 14 plus 3, you're still in debt. 14 is much bigger than 3. So this is negative 11y. And 10 minus 18, that's negative as well. That's negative 8x. Right? This one is interesting. People kind of get in trouble with this. You just have to take your time. Multiply the signs first. Minus by a plus is a minus. 5 by 2 is 10. X by x. What is x by x? Not x squared. Y by y is y squared. Okay. Then the next term, minus by minus is plus. 5 3s are 15. X by, well, I have no x's extra, so I just have the normal x. Y by y is y squared. Let's see now I get on this, right? That's just the first 2 terms there. Yes, you're multiplying the signs first, then the numbers, then take the letters one at a time. X by x is x squared. We're continuing here with this. Negative by a positive is negative. 7 4s are 28. Y by x squared, y squared is x squared, y squared, right? Minus by minus is plus. 4 by 1 is 4. Remember, 1 is understood here in front of this xy term. 1 is understood. 4 by 1 is 4. Y by xy is xy squared. Now we need to rearrange things, right? I have a x squared y squared here and a x squared y squared here. So let me just move that a little bit to the over here. And I have my terms lined up. This is going to give a bigger negative number, negative 10, negative 20. Remember, I have like terms together, so I just use the coefficients now. Negative 10, negative 20, it does, let me see. I could rewrite this. This is negative 38, right? And 15 plus 4 is 19. And we're done. Okay. Ask and ye shall receive. On my screen, I have 6 questions. I'll give you now till probably 6:30. I'll give you like a 15-20 minutes to do these, right? I really hope you all get all of these things correct. Okay. This is what we call expanding brackets, simplifying. So when they say simplify, they mean collect like terms together. When they say expand and simplify, they mean multiply the brackets, collect like terms together, right? Combine them. And usually at the end, you will factorize, but I haven't taught you all factorization yet. For those people who know how to factorize, you should always factorize your last, final answer, okay? Some of these questions cannot be factorized, but just by the very nature of it, you just don't have no letters or numbers in common, that's fine. Don't worry about factorization right now. Work on simplification, expanding and simplifying, okay? So do this for the next 20-25 minutes. Hope you all have fun. So, okay, for this question is basically organizing the terms next to each other, right? So you rewrite the question and you just put the like terms together. So I'll take the 12x squared y, put it next to the 4, right? The 5x squared, put it next to the 2, and the 8 and the 7 next to each other here, right? Now, what I'll get, 4 and 12, that is, let me see, this is 16, right? Minus 2 minus 5 is minus 7, and 8 minus 7 is 1. So take the number out, and that's the answer there for this one. Well, you just add any coefficients, right? For this one, we rewrite it over. We put like terms together. So I take the 2AB, put it next to the 9. Take the 4AB, put it next to this 2 here, and everybody else is like terms. So now we just add the coefficients. 9 plus 2, which is 11. 11 minus 4 is 7. Right? So all this here is 7. And minus 5 minus 7, that's negative 12. Negative 12 plus 3 is negative 9. Yeah, that's the answer there for that one. Now we come to questions that have a good bit of expansion in it, right? This is 20xy minus 35pq minus 15st, right? So 5 4s are 20, 5 7 is negative 35, 5 3s are negative 15. That's this first part here. Next part, minus 12st minus 6 by 2 is minus 12. Plus negative 6 by negative 8 is 48 PQ. And negative 6 by negative 9 is plus 54xy. Right? And then we should probably collect the like terms together. So let me see, I'll put this 54 next to the 20. I'll put this 48, it's positive 48 next to the 35. right? Should probably put that in our next line, right? Right, so I just combine the like terms together. 20 and 54, you can add them now. This is 74 here. Minus 35 plus 48. The signs are different, so when I add them, I'll get a bigger positive number. 35 and 10 is 45, and 3 is 48, so that is positive 13 PQ. And negative 15, negative 12, we just add them together and you'll get minus 27. Right, 74xy plus 13 PQ minus 27 ST. Next question here. This one is a good bit of work in. This is 15 m squared n minus 5 by 4 is 20, so negative 20 m n squared. This is negative 6 by 8, that's negative 48 mn squared. 6 by 9, negative 6 by negative 9 is plus 54 m squared n. Negative 7 by 2 is minus 14 mn squared. Plus, because negative 7, this is 1 here, right? This is a 1 here. Negative 7 by 1 is plus 7. Plus 7 m squared n. Right? And you should check over your work in the first line. 5 3s are 15, 5 was a negative 20, negative 48, plus 54, 7 2s are 14, there's plus 7. M squared n, mn squared, mn squared, m squared n, mn squared, m squared n. Right. So rewrite the question again and just put like terms together. So the 15 and the 54 could go together here. The 7 and the 20 right? So I have 3 mn squared terms. See, the 15, the 54, and the 7. M squared n, right? And these are mn squared here as well. So it's really just to combine them now. 15 plus 54, this is 5 and 4 is 9, this is 69. 69 and 70 is 76. So just write it back. 76. And all these terms are negative here, so add them up. 20 plus 48 is 68. 68 and 14, that's 78, 82. This is minus 82. Yeah, and then you could factorize this answer if you want, but we're not doing it yet because we haven't taught you all how to factorize. Next question. Let me see. Negative 7 by 2 is negative 14 m cubed n squared. All right. You do it in parts. Negative by positive is negative. 7 2s are 14. M by m squared is m cubed. N by n is n squared. Right? Plus, because 7 negative by negative is positive. 7 3s are 21. M by m is m squared. And n by n squared is n cubed. Okay. 6 by 8, that's negative 48. M squared by m is m cubed. And the n squared kind of comes along for the ride. Plus 54. Plus, because it's minus by a minus, is 54. M squared n cubed. Right? So check over everything. Sum to the negative 14. This is positive 21, negative 48 plus 54. M cubed n squared. M squared n cubed, right? M cubed n squared. M squared n cubed, right? I just want to rewrite this question to collect your like terms together. So this 48, I could put it next to the 14 here, right? So negative 14 minus 48, only 21 and 54. Now these two numbers are negative, so we just add them, right? Basically add them. So 14 and 48 when added would give a negative 62. And the 54 and the 21, this is 75 plus 75, right? So that's good there. And then, whoa, this last one, yikes. You take your time with this. Is 2 by 5 is 10, x by x is x squared, y by y squared is y cubed. That's the first term, minus 2 6 are 12, x by x squared, x cubed, y by y squared, y cubed. 3 by 7, there's negative 21, x cubed, y cubed, plus negative by, remember it's negative 3 by negative 8, that's plus 3, it's a 24, x squared by, you have no x's here, so the x squared remains, y by y squared is y cubed. Negative 4y plus 9 is negative 36. X by x, x squared, y by y squared, y cubed, and then plus, right? Negative 4 by negative 1 is plus 4. X cubed, y cubed. Right? So check over each line. Huh? 2 5s are 10, 2 by 6 is minus 12, negative 3 by 7, negative 21. Notice I check any numbers for it. Negative 3 by negative plus 24, minus 4 by 9 is negative 36, minus 1 is plus 4, right? This is x squared, this is y cubed, x cubed, y cubed, right? X cubed, y cubed, right? X squared, y cubed, right? X squared, y cubed here, and x cubed, y cubed, right? So now it's just to combine like terms. The 10, if I see x2y cubed, our x2y cubed here, the 24, right? So take the 24 and put it next to the 10. So 2, 3, 2, 3. I have another 2, 3 here, the negative 36. So I'm gonna grab this guy here, put it next to here, right? So all the x squared y cube, x squared y cube, x squared y cube, and 3, 3, 3, 3, 3, 3. Very good. And this should boil down into two terms, right? Now, 10 and 24 is 34. And 34 minus 36 is negative 2. Right? So that's negative 2 there. And then these three guys here, negative 12, negative 21, you add them, you'll get negative 33. And negative 33 plus 4 is negative 29. Okay? And then you can factorize this as well, at least the letters part of it. But those are the answers there I think I didn't make any errors. I think that those are the answers. So what I'll do, in the home page here, I will give you a new worksheet. I'll make a new worksheet for you guys. I'll add it here. What I could call it one. So I could just duplicate. No, let me don't do that. Does duplicate everything. So I'll call it algebra expand and simplify. Okay. So when you click on this, I'll give you some problems here, essentially. So me full width, empty, and voila. We'll take this out for now. We could work on these questions here. You have 25 questions, right? This is a new section. Next week, I'll teach you all how to use the HCF of terms to factorize, right? And then we will modify these questions to factorize as the last step. So we have a next worksheet here, algebra, 25 questions. We're not gonna give any homework for lecture 3 today. We kind of do a lot of work today, but what we did today was basic algebra, terms, expressions, like terms, how to add them. We did indices last week, so you know how to multiply. When you're multiplying out like here, you know, this is fairly easy, like x squared by x is x cubed, that kind of thing. This basic indices, yeah. It's just multiplying, we don't have divided and so on. So I hope this makes sense. And you could start working on the worksheet. And the other homework items, remember lecture 1, we had some homework at the end, and lecture 2, we had some very simple homework here. This is very easy, trivial stuff here. So I hope you all understand what I did here today.